Hi everyone, this is Mrs. Snowback. Today we are going to start Unit 10. Before we actually start the notes for 10.1, I want to take one slide here and remind you, how do you graph an ordered pair on a coordinate plane? And so remember, an ordered pair is an x value and a y value. The x always comes first, and the x tells you to go right or left. And remember, if the x is positive, you go right, and if it's negative, you go left. And the y value tells you to go up or down. And again, if it's positive, you go up. If it's negative, you go down. Remember what this point right in the center of your graph is called. That is called the origin. And the coordinate at the origin, remember, is 0, 0. Another thing I want you to think about is, what are the quadrants called? They're called quadrants 1, 2, 3, and 4. Where is the first quadrant? Where is quadrant 1? Quadrant 1 is right here, and I believe it's because in quadrant 1, both the x and the y are positive. Your coordinate has a positive x value and a positive y value. And then going counterclockwise, this is quadrant 2. This is quadrant 3. This is quadrant 4. Roman numerals. I don't know why they use Roman numerals, but that's what they generally do. Let's just take a quick practice. Let's say I wanted you to graph the point M at -1, 4. So think, what way would you go to graph that point? Well, the first number tells you left 1. The second number tells you up 4. So you would go left 1 and then up 1, 2, 3, 4. It would be approximately right here. That would be point M. Let's try another one. Let's go point A, and let's say that is at 3, -6. So I'll give you a second. Think about which way do you go. It should be right 3, down 6, and it should end up kind of down where I've put it on the graph there. And let's do one more. Let's do point T at -5, -2. Which way do I go? Left 5, down 2. Here's T. You know what? Let's do one more for fun. Let's do H at 3, 0. So where would H be if I did 3, 0? That means right 3, up 0. So H would be over there. One last thing I want to be sure to point out is the X and Y axis. I forgot to mention this. The x-axis, remember, is your horizontal axis. So it's the one going from left to right horizontally, like the horizon line. And the y-axis is your vertical axis. It's the one going up and down. So try to remember that too, which one's x and which one's y. Great, let's get started on Unit 10. So this is going to be Unit 10 Notes 1. In this unit, we are going to study various transformations. And the first one is called a reflection. And a reflection is when you take an object and you flip it over a line. Oftentimes that line is called a line of symmetry or a line of reflection. So let's jot down one thing here real quick. The nickname for a reflection is flip. Nickname for a reflection is flip. And so you take something and you flip it over like you're flipping a hamburger in the pan or on the grill. And you can see it kind of looks like a reverse of what you had to begin with. Think about, you get up in the morning and you see your reflection in the mirror and you say, "Hi self, looking pretty good this morning." Yep. Well, when you raise your right hand in your reflection, that reflection is raising their left hand. It's like the opposite of what's actually happening. It's a reflection. Let's get started. The first reflection that we're going to learn today is how to reflect something over the x-axis. So I'm going to start by having you graph 3 points. I'm going to have you graph A at 1, 1, B at 3, 1, and C at 1, 4. So will you please graph those 3 points? Put a point or a dot on your coordinate plane at each of those points. Be sure to label each point with the letter so you know which point is A, which point is B, which point is C, and then connect them with segments and make them into a polygon. So in this case, we're going to have a little triangle, triangle ABC. That is called our pre-image. That's our original image. And now what we want to do is we are going to try to reflect over the x-axis, or reflect in the x-axis. So to do that, and go ahead and read this right here, to reflect a point in the x-axis, you multiply its y-coordinate by -1. Now you might be thinking to yourself, I could eyeball this. I could reflect it over the x-axis pretty easily just by kind of eyeballing it and putting 3 more points and connecting them. And that's true in this case, but it won't always be this easy. And so I want you to learn it the mathematical way as well. And so the mathematical way is to leave the x-coordinate alone for each point and take the y-coordinate and multiply by -1. So our new A is going to be called A prime. It's an A with a little apostrophe by it. The first part, the x-coordinate remains 1, but if we take the y-coordinate, which was 1, and we multiply it by -1, we get -1. Our new B prime, or B with a little apostrophe by it, is going to be 3, -1. We left the 3 alone, but we take the second coordinate, the y value, and we multiply by -1. And our C prime is going to be 1, -4. And then we graph those new points. And so we're going to put a point at 1, -1, which is right 1, down 1, and we're going to label that A prime. And then we're going to put a point at 3, -1, which is over here, and we're going to label that B prime. And we're going to put a point at 1, -4, which is right 1, down 4. We're going to label it C prime. And then we can connect our new points. And you can see it looks like we took that original pre-image and reflected it over the x-axis. Remember, the x-axis is the horizontal line, or the horizontal axis. Let's try the next one. So the next one, what we're going to try to do is reflect in the y-axis, or in other words, we're going to take our points and reflect over the y-axis. Let's start by graphing our 3 same points. A can be at 1, 1, B can be at 3, 1, and C can be at 1, 4. So go ahead, take a second, graph those 3 points, label them, connect them. Now, to reflect in the y-axis, if you read down below, it says to reflect a point in the y-axis, you multiply its x-coordinate by -1. So think about this, you guys. Our new A prime, it was 1, 1. Our A up at the top there was 1, 1. Well, now we're going to multiply the x-coordinate by -1. So we're going to have -1, 1. We leave the y-coordinate alone. B prime will be -3, 1. We take that first number and multiply it by -1, and the second number we leave alone. C prime will be -1, 4. We have our new points, so now let's graph those new points. So -1, 1 is left 1, up 1. Put a point there, call it A prime. -3, 1 is left 3, up 1. Go ahead, put a dot there, label it B prime. And then C prime is at -1, 4, which is going to be left 1, up 4, and connect them. And it should look like your original triangle did a flip over the y-axis. Now remember, your y-axis is the vertical axis that goes up and down. So it did a little flip over that vertical axis. And the last one that we're going to study today is reflecting over the line y equals x. So you might be kind of wondering, where is the line y equals x? So it helps to make a little t-chart. If I do a little xy t-chart, if x is 0 in this equation, y would have to be 0. If x is 1, y would have to be 1. If x is 2, y would have to be 2. Whatever x is, y equals it. So x and y are equal. Where are those points? Well, 0, 0, 1, 1, 2, 2. You can kind of see the idea. I'm going to dot a line through here. This blue line that I just dotted in, that is the line y equals x. So we're going to start by graphing our same three original points. We're going to graph A at 1, 1, we're going to graph B at 3, 1, and we're going to graph C at 1, 4. So please go ahead and graph those 3 points, label them, connect them. So take a good look at this triangle, you guys. We're supposed to reflect this triangle over that slanted line. Weird. Half of it's on one side, half of it's on the other side. Well, what's going to happen is the points that are on the left are going to flip over it and down to the right. And the points that are kind of down on the right are going to flip over it up above to the left. And so you'll see what happens. Now read what our instructions are. It says to reflect a point in the line y equals x, interchange the x and y coordinates. What does it mean to interchange two things? Well, it means to swap them around. So if A was 1, 1, A prime, if I take the 1 and the 1 and I swap them around, it's still going to be 1, 1. B prime, instead of being 3, 1, will be 1, 3. C prime, instead of being 1, 4, will be 4, 1. I interchanged the x's and the y's. I flopped them around. And now let's graph them. So A prime is at 1, 1. I put a dot. It lands right on top of itself. It was on the line. If you reflect something over the line and it's on the line, it'll land back on itself. B prime is at 1, 3. So I go right 1, up 3. B prime, it was down below, or B was down below. Now B prime is up above. C prime is at 4, 1. So that's going to be over here. C prime. Again, it's kind of overlapping itself. This triangle ends up overlapping itself. And that will happen on your homework as well. So this is what your homework will be like. On each graph, you're going to graph the pre-image and the final image. So in this case, we're going to start by graphing the points for number 1. We're going to graph A, B, and C. So will everybody just pause the video and plot those 3 points, and when you're done plotting them, unpause the video. So here you can see I've plotted points A, B, and C. Now number 1 says reflect triangle ABC with these vertices in the x-axis. Remember, the x-axis is the horizontal axis. Could I eyeball it? Probably, but for your homework, underneath each graph, you are going to write the new coordinates and then graph them. So for instance, A prime, if we want to reflect over the x-axis, think about our rules from before. What we do is we leave the x alone, so we're going to leave the -5 alone, but we're going to multiply the y by -1. Remember that rule? Otherwise, you can always flip back to that previous slide to remember that. For B prime, you leave the first number alone, so it's going to stay at 2. You multiply the second number, or the y value, by -1. Well, 0 times -1 is still 0. The C prime, leave the first value alone, and you multiply the y value by -1, so that'll be -2. And then you plot your new points. So go ahead and pause the video again and plot these 3 new points and then unpause. And here's what mine look like. It should look like that red triangle on the top flipped over the x-axis. Okay, well, you guys pause the video, try number 2 on your own, graph the original points, then write down your new points, and then graph your new points. And then when you're done with all 3 parts, unpause the video. Here you can see my pre-image, JKLM. So I plotted those points, check if yours are correct. Now on this one, we're going to reflect in the y-axis. So that means over the y-axis, which is this vertical axis. So to do that, we leave the y alone and we multiply x by -1. So j prime was -4, 6. So we multiply the first number, the x, by -1, so it should be +4, 6. K prime, you multiply the first number by -1. Well, 0 times -1 is still 0, so that's going to be 0, 6. L prime is still going to be 0, 2. And M prime, if you multiply the first number by -1, you will get a +4 and then 2. And then go ahead and graph your final points. Hopefully you already did. And here are my final points. Notice I label all my points. So I have J, K, L, M, and then I have J prime, K prime, L prime, M prime. You have to do that on your homework. You have to draw both shapes, write your points down below, and make sure you label both shapes. Line of symmetry. So lines of symmetry, you guys, you've been studying these since you were really little, probably even as small as preschool. Let's write down the definition. Line of symmetry is a line that can be drawn through a figure so that one side of the figure is the reflection image of the other side. I'll read the whole thing again. A line of symmetry is a line that can be drawn through a figure so that one side of the figure is the reflection image of the other side. That means that if you cut the object in half, the two halves are reflections of each other. So take a look at number 3. It's a kaleidoscope image. State whether this object appears to have lines of symmetry. And if it does, go ahead and draw in all their lines of symmetry and then state how many does it have? How many lines of symmetry? It might have more than one. So I'm going to pause the video. You draw in all your lines of symmetry and then tell me how many you have. So from each indentation, it goes across to a point. And so you can see here, I would draw in from an indent to a point. I think I got them all. And so now if I count them, this is 1, 2, 3, 4, 5, 6, 7. And when I get to this top part, if I go down below, I've already counted it. So I think this had 7 lines of symmetry. Take a look at number 4. Do the same thing. Think about where are the lines of symmetry, draw them in, tell me how many, and then also the thing I want you to know is all the little decorations would also have to be symmetrical. Like the line of symmetry, even the decorations have to match up. I'm looking at this and I don't think the decorations match up at all. And so I think there are no lines of symmetry or none that we could draw in here and be able to like cut the object in half so the two halves were reflections of each other. Please pause the video and try numbers 5 and 6. When you're done, unpause the video. Number 5, the answer is 3. There would be 1, you can see that cuts it in half, 2, and 3. And notice all of those lines of symmetry happen to meet at one point. If it helps you to use a ruler to do this, feel free to grab a ruler or some kind of straight edge to draw nice straight lines. And for number 6, I'll give you another second if you need to pause the video. Number 6 is actually none. If you tried to cut it here, when you fold it over, it would actually go kind of like this and it would not match up. See how the corners wouldn't match up? Some people think, well, maybe it works diagonally, but try to visualize that. If you try to cut it diagonally, this part will go like that. So this would end up over here, and it's not going to match up. And so, as you already know, this one has none. Last two, pause the video, draw in all lines of symmetry, and for number 7, circle your answer. Number 7 is 1. This is a trapezoid and it could be folded down the middle, but that's it. And with the butterfly, also only one line of symmetry. Next, please try Unit 10, Practice 1. If you need help, let me know, and have a great night.